Hello everyone, I'm Eric. Today I will discuss a crucial and challenging topic in the field of bioinformatics, privacy and sharing the genomic data. With the rapid advancement of sequencing technologies, genomic data has become a treasure trove of infinite value. However, how to safely mine this treasure while safeguarding the source of data? Our personal privacy. Next, I will elaborate our four parts. First, let's look at the framework of today's report. I will first explain why genomic data is so important. Second, explore the background and core concerns of data privacy. Then analyzes the ethical and legal challenges facing privacy protection. And finally, introduce some key technological measures currently addressing those challenges. Let's move to the first part, the importance and application of genomic data. Genomic data in simple terms is that digital representation of our life grouping. It's not just a sequence of ATG-CG. Its importance is first reflected in base research and clinical diagnosis. Next generation sequencing technologies has become the cornerstone of research and clinical practice, enable us to rapidly and cost-effectively interpret genetic information. Secondly, there is multi-omics integration and disease research. By integration genomic data and other data, we can analyze the roots of complex disease such as cancer. One of the most important applications is promoting the revolution precision medicine. Based on individual genomic information, we can predict disease risk, choose the most effective drug, and avoid adverse reaction, truly achieving treatment tailored to individuals. Such a valuable resource naturally brings us to the second part, the background and core concern of data privacy. What is data privacy? Here is referred to preventing personal genomic data information from being collected, used, and disclosed with organization. Why is so important? There are three key reasons, each of which is crucial. First is leader to discrimination and disclosure of sensitive information. Imagine if you generic predisposition to disease were known by employer and insurance companies, it could affect your employment and insurance right. Second, it affects individual and their relatives. Our genes are shared with family members. The disclosure of one person data may expose genetic secure of the entire family. Third, and most fundamentally, while the password can be changed, your genome is lifelong biological identifier that poses a lifelong risk once exposed. There's no alarmism. Commercial genetic testing companies such as 23andMe have faced the risk of data being sold and leaked multiple times. The media often reports on the five major risks of handing over DNA to consumer genetic companies like hacking, loss, effect companies are sold, and last, if your DNA information are sold, who may profit on your DNA? The answer is not you. This case warns us that privacy risks are real and imminent. In fact, of those risks, we naturally seek legal and ethical protection, but this leads us to the third part. We face some ethical and legal challenges. On the regulatory front, represented by EU GDPR, the GDPR treats genetic data as special category data, setting very high processing thresholds and emphasizing the need for adequate technical and organizational measure for protection. This is an important regulatory framework. However, the law is not comprehensive. The shadow of genetic discrimination still looms large. report from 2022 shows that discrimination based on genetic information still exists. People worry about being treated unfair in employment and insurance due to genetic defect. Additionally, the risk of data misuse comes from multi-sources. Law enforcement agents accessing genomic database for investigation may trigger privacy boundary disputes. Government may use genetic data to monitor and target special groups. A drug making company have huge demand for vast amount of data to develop new drugs. How can we balance commercial interest with personal privacy? This strategy indicate that protecting genomic privacy is not only a technical issue, but also a profound social and ethical proportions. So on the technical level, what weapon do we have to respond to those challenges? This leads us to the fourth part, the technical challenge and solution for privacy protection. First, the base defense data encryption and security transmission technologies. Those ensure that data is not stored during the store and transit. However, more often we need to share and utilize data here. The identification is key. For example, HIPAA Act stipulate the removal of 18 types of personal healthy identifier, but this is only the first step, as simple removing directly identifier may still allow the re-identification through the data linkage. Therefore, more advanced technology has been developed, mainly include three types. First, generalization and aggregation, transforming precisely value like 33 to 30 to 40 to hide the individual while retaining group statistic characteristic. Second, adding the noise to the original data to slightly distort the value while maintaining the overall data distribution relationship for the analysis. Synthetic data. This is an emerging and powerful idea. It does not directly modify the original data, but use AI model to learn the real data, then generate a batch of the entire new visual patient data. This synthetic data has not real individual counterparts, but can highly simulate the structure and pattern of the original data for research to use safely. This technology represents the wisdom of working the tightrope between the data available and personal privacy. This is the reference, and thank you.